Well, I guess we're going to get started. I didn't hear any time to go, but I'll do it anyway. I'm trying to record this. That's why I got the mic, because I thought if parents can't show up, maybe I can put it on YouTube and they can watch. We'll see how my little experiment goes. I don't know. How do I look, everyone? Hey, welcome. My name is Chris Stoker, and I teach conceptual physics. I love teaching it. To me, conceptual physics is physics for everyone. And when people think of it, they kind of think, oh, it must be like watered down physics and you don't do some of the hard stuff. No, it's not really that at all. What it is, conceptual physics, is we pull out most of the math. We still do some math, but we pull out a lot of the higher end math and we focus on, can you explain the concepts? Do you understand them? Can you apply them? And from teaching college level physics as well with AP and stuff, I've found that a lot of times it's the concepts that students think they know that they don't really know, and not so much the math that trips them up. And so this is a great foundation class, even if it's the only physics they take in high school, for going on in any sciences in college or taking any science classes, as well as if they wanted to take AP in high school, they could do that as well. So I just am a big believer in it. I think it's great. But I wanted to start with a demo because, well, it's cool. I have here the classic tablecloth tug, dishes, glass. I'm going to pull this out. You haven't seen this yet, right? So this is a preview of things to come. Okay. Can I get like a drum roll or something? Okay, thank you. Here we go. 1, 2, 3. Thank you. Okay. Thank you. I'll be here all year. Okay, so I may or may not assign this as homework to do over Thanksgiving. I will not confirm nor deny if that happens, but we do talk about the physics behind this. But what is important to me is that they have to predict what will happen and why it will happen before we do it. Because what I've found is if you force them to predict and do it in writing, that they're thinking, at least subconsciously, about what the ideas are in their head for whatever this is, you know. And that it works much better if they've already pre-thought about what they think will happen, and then they're confronted either with something that does work that way or something that doesn't. And when it doesn't work the way they think it will, which will happen a lot to them in this class, because they have fairly limited experiences with life and with physical motion and things, when they have something that doesn't happen, there's really two options. One is they'll get that awkward feeling that we all get when we thought we knew something and we don't really understand what's going on, and it's like confusing and it kind of hurts your head. When that happens, they'll either try to sweep it under the rug and say, I never was good at math and physics, or, this is the part I keep my fingers crossed about, they'll say, well, what really was going on? And then they'll start to rebuild the idea in their head, kind of more like Legos or something. So my job, I see it as to help them look at the Legos that are there, kind of, compare them to what's really going on, and then as they need to rebuild throughout the year. Rather than the idea of teaching being, here they are empty cups and here I am the font of all knowledge, and I just dump it in. So I do very little straight like lecturing and stuff. I try to design activities or experiments where they are at least touching on the ideas and thinking about them before we ever try to make sense of them. Okay. So let me talk about one difference between conceptual and AP, because I think this might help to clarify kind of the level I'm talking about. Let's say this is a plane. Let's just say it's a plane, okay? The plane is going a certain speed in this direction, and a wind comes up and blows it straight sideways. So maybe they're having to figure out, well, what speed would the plane actually have? Well, we know that the plane is going to move kind of a diagonal if the wind's blowing it, right? So in conceptual, I would expect that they could, once they're taught, take this arrow and move it to right here, as if the plane kind of goes this way and then the wind takes it straight sideways, as if those happened in 2 steps. And then combining those and saying that's the actual motion and kind of making this right triangle. I would expect that they could do that. Then I would expect one layer of math from the conceptual classes and say, well, they should also be able to use our friend Pythagorean theorem, a squared plus b squared equals c squared, and come up with the actual speed that this plane would be going with the wind helping it. In AP, same kind of thing, only now the wind is coming at some crazy angle, and they'd have to be able to figure out the angle that comes out, and it would involve sines and cosines and some of that uglier stuff. It's still the same sort of concept, really, when you boil it down. It's just different levels of math involved. So some other things that that you'll want to know, I would think. They can retake tests and get up to an 80% on it. They can turn in late work as long as we're still in the current unit. This motion unit will go till about October 1st when we take the unit test. So anything that's late in that time, they can turn in for partial credit. I said retake tests. They can get up to an 80% on that, as well as quizzes. And something new I'm trying this year is some projects. They'll be worth a chunk of the grade. The projects are for students who want to get an A, basically. If you want to get an A, to get to the A level, you have to apply what you know in some sort of a project, or maybe even the upper B level. And so there will be some class time for that, but most of that will be out-of-class work that they're doing. And when they have class days to do it, that will then give me time to help remediate students who aren't quite getting some of the basics down. So if students struggle, MAV time is the perfect time for them to come in. It's in the morning, and so students don't want to come in early that often, but I actually have the most time in the morning to help if they can make arrangements to get in here at that time. Questions?
So on the to get an A with the projects, you're going to be telling the students that, right?
Yeah, we've talked about it. There's going to be a rubric for the projects going home. The truth is they don't really pay attention until it's about the first test, and then they're thinking about the grade. So I kind of wait to give them all the details until they really are paying attention to it. You know.
But you'll let them know we don't need to do that.
Yeah.
Okay.
And we've already talked about due dates and some of that stuff. Other questions? You want to see one more cool thing? We've been playing a lot with the motion detectors. And let me just show you in the 30 seconds I have left how these kind of work. They work off sound waves going out from these little boxes, hitting an object, and then coming back.
Third period, 5 minutes to get to fourth period, 4A on your schedule.
If you stand in front of them, it tracks your motion, so kids have to map out how they think they're going to have to move, and then they have to get in front of the motion detector and see if they were right. So it's instant feedback on if they're understanding the ideas or not. Thank you for coming, parents. You bet.